Hi guys, it's really important that you practice your chemistry skills in order to get really good at them so that you don't have to think about these things when we start talking about the more complicated reasons for why things happen. Figuring out why is harder than figuring out how, so you need to get the how down before we move on to the why. Here are things that you can practice doing with this tutorial. You can practice finding the number of electrons, the number of valence electrons, the number of neutrons, the number of protons, and the total number of nucleons in a particular atom using the periodic table. You can practice drawing Bohr models of atoms with this tutorial, and you'll be able to locate the group number and the name of the group as well as the period number for a particular atom. And then you'll also be able to find the atomic number, atomic mass, and the mass number of the most common isotope. So we're going to do all of that over and over again, and you can use this tutorial as much as you would like, and probably the best way to do it is to make good use of your pause and fast forward buttons, because all you're really doing here is practicing. So get yourself a piece of paper, a nice piece of loose leaf or something, and just sketch out the answers and then check them against mine. For each problem that I do, I will go back and explain how I got that answer. Okay, ready? Okay, first atom up is potassium. Potassium actually has the symbol K, which is something that you may not have realized. I've taken the part of the periodic table we need to do this. Here's potassium right here. If you're having trouble finding a particular atom on your periodic table, you can always type into the search bar up in the upper right-hand corner the name of the element, and it should bring you to it. So there's potassium. So we need to find first the number of electrons in potassium. And the number of electrons is equal to the atomic number, which is 19. So we're going to have 19 electrons. We're also going to have 19 protons, and the atomic number is going to be 19. So just looking at that number 19 tells us a whole bunch of things. It tells us the number of protons, the number of electrons, and the atomic number of potassium. Okay, so now it's asking me about valence electrons. The word valence just is a fancy way of saying outer or outermost layer. So the outer layer of electrons is shown here in this stacked set of numbers. So the bottom one is always your valence. So it's kind of hard to read on here because when I blow it up it gets a little bit fuzzy. But on yours you should be able to tell that that is a 1. So we have 1 valence electron. To get our neutrons we have to do a little bit of math. We have to round this number, which is 39.09, so that'll round down to 39. And we have to subtract the 19 from that, because that is the number of protons, and this, the mass, is the number of protons and neutrons, so the difference between the two gives us the number of neutrons. So 20 neutrons. Now, we want to know how many protons we have. We already figured that out. That's 19. That's the same as the electrons and the atomic number. Nucleons refers to protons and neutrons together. So how many of those do I have? Well, I have 19 protons and 20 neutrons, so I must have 39 nucleons in the nucleus. The number of the group that potassium is in is 1. Groups are the columns. And this group actually has a name. If you look at the key in the middle of your periodic table, you'll see that the name of this group is the alkali metals, and it's color-coded on the one that you look at on your iPad. And then we also have to know what period we're in, and so that's the row that we're in, which is this row, and that's period 4. Periods don't have names, but groups do. We already did the atomic number. It was 19. The atomic mass is that number I circled down here at the bottom, right here. And that is the whole unrounded number we would write for that. So we would say 39.0983 is our atomic mass. And our mass number for the most common isotope is that number rounded. So 39 is for the most common isotope. What that means is that the most common version of potassium has 20 neutrons and 19 protons, and so it has a mass of 39. The fact that the unrounded mass is a little bigger than 39 should tell you that there must be a version of potassium that's a little bit heavier than the normal one, and the only way for that to happen is if it had another neutron. So there must be some potassium atoms out there wandering around with 21 neutrons, but when you average them in, they're not very many, so they bring up the mass only a tiny amount. Now we want to take all this information and use it to make our Bohr drawing over here on the right-hand side. So to do that, the way that I like you to do it is to just write in the letters P and N. So P for protons, N for neutrons, and write in the number of each that you have. So we already determined for potassium that we have 19 protons, that's just our atomic number, and we have 20 neutrons for this particular isotope. The next step is to figure out where your electrons go. And you can use the periodic table for this too. This tells you how many electrons there are in each of these little ringlets, right? So we have 2 in the first shell, and they always go together up in the top. And you try and get them on the line, but on the iPad it's hard. And then the next row is the next shell is going to have 8. And remember, there's a way to fill these out. Watch what I'm doing. I'm going around the horn here. And the next shell actually also has 8. Just like so. And then there's actually another shell, which unfortunately this particular model doesn't have drawn yet. So I'll just kind of sketch it in. So I just kind of sketched it in a little bit. How many electrons are in the valence shell? Just 1, and it goes right up there. And that is the Bohr model for potassium. Now, let's see how many of these you can do on your own with, just a little bit of guidance from me. Let's try and do this for another atom. Okay, here we go. See if you can find all this information for the oxygen atom, and then go ahead and draw him. I put just the part of the periodic table that you need over here on the left. Go ahead and pause and then come back. Okay, so the number of electrons that it has is 8. That's the atomic number, which is above the O in the picture. It has 6 valence electrons. That's the little number down here, right down here, right there. And it has how many neutrons? Round this. 15.9 becomes 16. Subtract this. That's 8 neutrons. And it has 8 protons as well, which is the atomic number, right, above the O. And altogether, the nucleons then are 16. So we can go ahead and draw those into our Bohr model. P and N, 8 and 8. Okay, so now we have to put our electrons in. And we can see that the first shell is going to have 2 electrons, and they always go right by each other, right there. And the next one has 6, and it's really important that you put them in like this. The first 2 together, the third in the east corner, then come down, then go over. So that's 1, 2, 3, 4, 5. We need 1 more, so now we double up like that. Also be careful that you don't accidentally put this electron here in that shell. That's very common. I do that all the time by accident, and that would make your answer wrong. Okay, so that's our Bohr model. The group number for oxygen is 16, and that is one of the other nonmetals is the name of the group. And the period is actually 2. It's in row 2. The atomic number we already said, it's 8. It's right above the O above the symbol. The atomic mass is this number down here, unrounded, 15.994. The most common isotope has a mass number of 16. That's the rounded number. Okay, ready? Let's do another one. Okay, since it's right next to oxygen, why not do fluorine? Okay, you ready? So find the number of electrons. Well, it's going to be the same as the 9 because that 9 tells us both protons and electrons. So there's 9 electrons. Valence electrons are 7. That's the number at the bottom of the stack in the upper right-hand corner. The number of neutrons I have to get by rounding the atomic mass, which is 18.99 blah, blah, blah. So we're going to round that to 19 and then subtract the 9, and that gets me 10 neutrons. Might as well pop those into our Bohr model. So we know that we have 9 protons because of this number here, right? And we know that we have 19 minus 9 for our neutrons, so that's 10. And the total number of nucleons then in the nucleus is 19 because there's 10 neutrons and 9 protons, and those are the nucleons. Now I'm going to add in my electrons. According to the electron configuration that's written here in the corner, I need 2 in the first shell and 7 in the next shell. Remember to spread them out. 1, 2, 3, 4, 5, 6, 7. So that's the Bohr model. The atomic number is 9. That's this number right here. Our atomic mass is this number, unrounded, 18.99 blah, blah, blah. And our most common isotope is the rounded number that we just looked at there. So instead of 18.99, that's 19. So that's it for fluorine. Let's do another one. Alrighty, how about beryllium? Okay, so the number of electrons in beryllium is going to be 4, because that's the atomic number up above the Be. The number of valence electrons is going to be 2, because that's the bottom number in the stack. The number of neutrons I have to subtract, so I have to round my mass from 9.012 blah 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 to 9, minus 4 is 5, so I've got 5 neutrons. I have 4 protons, that's going back to the atomic number again. And I have a total then of 4 protons and 5 neutrons for 9 nucleons. And I'll write them into my Bohr model right now. So we have 4 protons, 5 neutrons, and that's why we have 9 nucleons. Now we have to draw our electrons. We have 2 and 2, so there's 2 in the inner shell, and there's also 2 in the outer shell, and that's beryllium as a Bohr model. The atomic number is 4. The atomic mass is 9.012182. The mass number is that number rounded to 9, and that's the most common isotope of beryllium. Okay, let's do one more, and then hopefully you'll be able to do this on your own. Okay, let's do lithium. You ready? Find the number of electrons for lithium. Lithium has 3 electrons. Find the valence. He has 1 valence electron, bottom of the stack. His neutrons we have to round 6.94. I think that's a 6.94. That rounds to 7. Minus 3 is 4 neutrons. There's 3 protons, that's the atomic number. And 3 and 4 add up to 7. Pop those into our nucleus. We have 3 protons, 4 neutrons, that's 7 nucleons. Oh, I forgot to do this before for beryllium, but we should find the group and the period, right? So the group number for lithium is 1, and the period number is 2, and lithium is in the alkali metal group. Beryllium is in the alkaline earth metals, and he's in group 2, but he's also in period 2. Sorry about that. Okay, so now we have to add in our electrons. So lithium has 2 inner electrons and 1 valence electron, like so. The atomic number for lithium is 3. The atomic mass is that number unrounded, 6.941. And the mass number is the rounded number, 7. Okay, hopefully that's starting to make sense to you. You can get lots of practice using the worksheet that I gave you, and I will see you guys in class.